So it's well understood that expectations regarding future climate drive private adaptation and mitigation, as well as support for public action. These expectations are rooted in political beliefs, but also social identity, but personal experience can also influence belief. And we're going to be looking at personal experience in this presentation. Now, cross-sectional studies have found that personal experience with weather in particular is associated with belief in climate change. And this has been demonstrated for things like drought and rainfall and hurricanes, things like that, extreme weather events. The thinking here is that personal experience makes climate change more salient, and this is Kahneman's idea of the availability heuristic. But there's an alternative hypothesis. So this author Whitemarch, 2008, showed that US flood victims were indistinguishable in their beliefs about climate change from individuals who didn't experience flooding. In other words, this additional signaling did not cause any belief updating. And one potential explanation for this is confirmation bias or motivated reasoning. And the idea there is that new information is filtered and processed in a manner that confirms prior beliefs and attitudes. So whether you believe hypothesis 1 or 2, there's at least 2 limitations in much of the previous literature. The first of those is that most of these studies have used cross-sectional data. So it's been really difficult to statistically identify the effects of experience. And those that have found that the effects of experience are much smaller than the effects of personal characteristics, for example. And the second problem is that it's plausible that climate change beliefs influence interpretation of extreme events rather than the reverse. So as far as I know, there's only been maybe 3 studies that use panel data to analyze climate change beliefs. And among these, well, here they are. So Carleton found just a 0.8 percentage point increase in the share of agriculture advisors who report believing in climate change following the worst drought in 25 years in the US. Palm and co-authors found that neither summer temperatures, drought, fatalities, injuries from natural disasters, or crop and property damage from natural disasters affect belief among panel survey respondents. And perhaps the most interesting is this study by Osberghaus, who looked at climate change belief before the biggest flood in decades and then after. And what he found was that the flooding hardened their beliefs. So climate change skeptics continued to be more skeptical after the flooding, and climate change believers were more believing after the flooding. All of these results are broadly consistent with confirmation bias, in which new information reinforces this previously held expectation regarding climate. So in this presentation, we used panel data from a national survey of farmers, foresters, and growers to analyze belief updating in the context of normal fluctuations in soil moisture. And that's an important difference. We're looking at normal fluctuations in soil moisture, and this is, of course, important for farmers. This is co-authored with Patrick Walsh. I'm glad that Patrick is joining us today. And here's what we find. We find that new signaling in the form of more intensive drought is associated with increased expectations regarding future drought, especially for people who did not previously expect drought to increase. New signals, whether it's in the form of wetter or drier soils, it doesn't matter. It has very little bearing on the future expectations of those who already expected future drought to increase. So the data come from the Survey of Rural Decision Makers, which is a repeated cross-section conducted every 2 years since 2013. It's all about land use change, and land management practices. It covers the entirety of New Zealand, as well as the entirety of primary industry. And we're going to be using the last 2 waves of the survey, 2017, 2019. And between those 2 waves, we have just over 1,500 people that we can link individually based on email addresses. And that's what we're going to be using for this today. So in 2017, we asked, how do you personally expect the prevalence of drought in your district to change by 2050? This was a very straightforward question. People would just say decrease a lot, decrease somewhat, no change, increase somewhat, increase a lot, or they're unsure. In 2019, we changed the question to more closely reflect how the question is generally asked in European studies, and this way we can hopefully come up with some comparative analysis. So the first thing we ask is, do you think that climate change is already affecting New Zealand, or that it won't affect New Zealand? And if it is affecting New Zealand, or will in the future, will it affect the frequency and intensity of drought? And then if so, how do you personally expect it to change? And so we have a sort of a mapping onto the 2017 questions rather. It's not identical, but it's closely related. So this is the full transition matrix for beliefs in 2017 and 2019. But because being unsure about future drought can either reflect true ambiguity where they just don't know, or it could be a result of the complex coding in 2019, I'm going to drop anyone who responded unsure in either year from most of the analysis. We'll come back to that at the end. And so here's the distribution without the unsures. Now, if you look at the people in the lower right here, these are people that thought that drought would increase in the future as of 2017. And you can see that 80% of them continue to hold that view in 2019. In contrast, if you look at people who thought that drought was going to decrease in 2017, and you look at whether they continue to hold that belief in 2019, it's only 2% of them that do. In fact, the people who thought that drought was going to decrease in 2017 are now overwhelmingly expecting drought to increase. So we're going to measure drought using the New Zealand Drought Index. Drought is not uncommon in many parts of the country, and certainly farmers, foresters, and growers know about drought. They're resilient to soil moisture deficits. But of course, severe and prolonged drought can significantly reduce agricultural production. It can affect animal health. It can disrupt rural industry. It can result in hardship in general. In fact, in 2013, GDP fell by 0.6% due to the drought and led to a decline in the exchange rate. So in other words, drought is highly salient for farmers. So to measure drought, we're using the NZDI, the New Zealand Drought Index. This is a composite of 4 existing indices chosen due to sensitivity of rainfall, to data availability over time and space, interpretability, and the balance of absolute and relative indices. They're measured at weather stations across the country. There's about 100 of them. We're going to use 76 in our analysis because those are where the people live. And the index is on a scale of 0 to 2. And so the closer to 0 you are, the wetter it is, and the higher, closer to 2 you are, the drier it is. And NIWA, who calculates the NZDI, very helpfully comes up with these different categories. So you're in drought if you have a drought index of 1.5 or above. Because New Zealand farmers are disproportionately impacted by drought during summer and autumn, we're going to focus on drought in those months. So here's the transition matrix comparing soil moisture in summer and autumn 2017 to soil moisture in summer and autumn. I'm sorry, summer and autumn of 2019. And I'd like to point out a couple of things. So first, neither year is really remarkable in terms of drought, or for that matter, rainfall. And second, there's a huge amount of movement between 2017 and 2019. So places that were dry in 2017 were often wet in 2019 and vice versa. So rather than focusing on extreme events like most of the literature has, our analysis is going to emphasize marginal changes in soil moisture. And given the panel nature of our data, our analysis is going to focus on the difference in the drought index between 2017 and 2019. So in particular, we're going to use logistic regression. And here we have expectations of future drought as reported in 2019. We're going to regress that on expectations of future drought as reported in 2017. And we're going to have an interaction term with soil moisture. Now, all of your time invariant individual level characteristics such as gender and identity and risk profile, this has already informed the 2017 beliefs, so we're controlling for these individual level factors. Okay, we're taking advantage of the panel structure. Our main analysis uses the difference in the maximum monthly NZDI because we think it's a conservative measure of soil moisture, but we're going to relax that at the end of the presentation. So here are our results. Beta 1 tells us that people who expected drought to increase as of 2017 are disproportionately likely to believe that it's going to continue to increase as of 2019. And beta 2 tells us that soil moisture in 2019 influences expectations of future drought as of 2019. Gamma tells us that this is especially pronounced for people who previously expected future drought to decrease or stay the same. In fact, for people who already expected drought to increase, current soil moisture has very limited signaling value. Just to concretize that, I'm going to show you how this looks in graphs. The red line here shows predicted values for believing that drought will increase as of 2019 for people who already thought that it would increase as of 2017. And the blue line shows predicted values for those who did not think it would increase as of 2017. Everyone is arranged on this graph based on how dry 2019 was compared to 2017. And so we have the wetter, 2019 is wetter than 2017 here on the left and drier here on the right. So the red line is basically flat, which means that soil moisture has only a modest impact on expectations of respondents who already thought that drought would increase. And in contrast, the blue line is really steep. And that means that those who did not previously expect drought to increase, they're really influenced by new information. So drought skeptics are more likely to change their minds based on new signaling. So these are our NEWA's thresholds that I showed you earlier, and we can look at this in a non-parametric way as well. And here you can see that while the predicted probabilities no longer rise monotonically, wetter conditions are still generally associated with lower expectations regarding future drought. This is wetter. The drier it gets, the more likely it is that people think that drought is going to increase in the future. And this is, there's basically a flat line for people who already expected drought to increase, but a very steep line for those who thought in 2017 that drought would not increase in the future. Now, the question was asked as to whether you strongly disagree, strongly disagree or disagree, or you're neutral about drought in the future, or you believe that it will increase, you're going to believe that it's going to increase a lot. So there's lots of different categories there, and everything I've showed you before was put into a logit which says that drought is going to increase or it's not going to increase. We can also disaggregate expectations regarding future drought into three categories. Drought will decrease, drought will not change, and drought will increase. And here I'm reporting the predicted probabilities in table form. So for people who expected drought to increase as of 2017, the predicted probability of expecting drought to increase as of 2019 exceeds 0.85. So it's really high. In other words, whether it's wetter or drier, you don't change your mind very much. For people who expected drought to decrease, they have overwhelmingly updated expectations. And again, these are reasonably high values. But for respondents who expected no change in drought as of 2017, they're much more likely to continue to hold those beliefs in 2019, especially if soil moisture is wetter in 2019 than it was in 2017. And as soils turn drier, this group increasingly expects future drought to increase. Just a couple of final results, and then I'll wrap up. I mentioned that we looked at the differences between the highest monthly NZDI previously, but we can instead look at different types of differences, including the mean of the monthly maximum, the maximum of the monthly mean, or the mean of the monthly mean, and you can see that the results continue to hold. And finally, I mentioned that we remove the unsure responses from the results. And if instead we assume that unsure means no change, then the results are more or less the same. So where does this get us? Signaling matters, but in this case, it matters much more for drought skeptics than it does for drought believers. And I will end there and be very happy to take your questions.